What if I told you that one of the most iconic cars in TV history was secretly a blueprint for the future of artificial intelligence? Seriously. So today, we're going to dig into how KITT from Knight Rider basically predicted the powerful tech that's starting to run our world, connecting a piece of 80s pop culture to the very real AI that's all around us now.
Okay, so let's just dive right in. The big question is simple. How on earth did a show about a talking car, back in the 1980s, manage to predict some of the biggest tech breakthroughs that we're only just now seeing come to life? I mean, it seemed like total fantasy back then, but the core ideas, they were surprisingly, and I mean surprisingly, on the mark.
All right, so to really understand the future that it predicted, we've got to start in the past. We have to start with the vision of KITT itself, because this wasn't just a car, right? It was a character, it was a partner, and it was a complete technological marvel for its time.
Man, for anyone who grew up in the 80s, those words, they're just iconic. Knight Rider was this global cultural phenomenon. Critics, yeah, they kind of panned it. It's got a measly 35% on Rotten Tomatoes. But audiences didn't care. They absolutely loved the fantasy of this lone hero and his super smart car solving problems the high-tech way.
So what could KITT actually do? Well, the show imagined a car with a brain, a self-aware processor that was always learning. It had a natural conversational AI you could just talk to, a shell that was basically indestructible, and of course, turbo boost. Now, while a lot of that seemed like pure science fiction, that core idea, the idea of a powerful, self-contained computer inside the car, that right there was the seed for a total revolution in the real world.
So, if we've had powerful computers and the internet for decades, why didn't we get a real-life KITT sooner? Well, the answer isn't really about raw processing power. It's about a fundamental problem of physics, really. It's about the universal speed limit of data itself. And that's a fair question, right? I mean, we have these massive, incredibly powerful AI models sitting out there in the cloud. Why can't a car just tap into that huge brain to drive itself? Well, the reason comes down to one little word: latency.
Okay, let's walk through what actually happens in a cloud-based system. First, the car's camera sees something in the road, but then that data has to travel, sometimes hundreds of miles away, to a server. The server thinks about it for a second, and then sends a command all the way back. That round trip, no matter how fast your network is, takes critical time. Time you just do not have when a crash is about to happen.
And that right there is the fundamental conflict. A self-driving car needs to make life-or-death decisions in milliseconds, but the very physics of sending data to the cloud and waiting for a reply introduces a delay. And for functions that are safety-critical, that delay is just not acceptable. You can't afford a buffer when you need to brake.
So how do we solve this? How do we get KITT's instant reflexes? Well, the solution is actually pretty simple in concept. You stop sending the data so far away in the first place. And this brings us to the whole world of edge computing. Edge computing basically flips the whole model on its head. Instead of one giant, centralized brain in the cloud, it puts the processing power right where the data is being created, out at the edge of the network. So for a car, the edge is the car itself. The thinking happens right there.
And this comparison just lays it all out, right? With edge computing, your latency drops to almost nothing because the thinking is local. It also means the system can operate completely offline, which is, kind of important if your self-driving car goes into a tunnel and loses its internet connection.
Okay, so we have the problem, latency, and we have the solution, edge computing. So now for the fun part. Let's look at how this exact blueprint is being used today to build real-world technologies that are finally making KITT a reality.
Think about it. KITT could see the world and react in a split second. Well, today's autonomous vehicles do the same exact thing, and they are the perfect examples of edge computing in action. Tesla, for instance, uses a vision-only system. Its cars are basically supercomputers on wheels, processing all that camera data right there, on board, to figure out the world around them. And the amount of this local processing is it's staggering. To make a single driving decision, Tesla's computer crunches through the equivalent of 2 billion little pieces of visual information, or tokens. This insane level of computation has to be local. It has to happen on the edge. There is simply no time to ask the cloud for permission to swerve. And this need for KITT-like reflexes, it's not just for cars. Look at the world of finance, where fraud detection has to happen in under 100 milliseconds before a transaction can even be approved. Or think about a smart factory, where a robotic arm can't just sit and wait for a signal from the cloud to make a precision weld.
The bottom line is clear. Any process that requires an instant response is a perfect job for edge computing.
And what about KITT's famous voice? Well, back in 1982, voice recognition was, let's just say, super primitive. You had to pause between every single word. But you can see the evolution here. And today, when you say, "Hey Siri" or "Alexa," the processing for that wake word happens right on the device itself, on the edge, so you get an instant response, even before it sends your actual question to the cloud.
So look, this is bigger than just cool cars and talking speakers. What we're really witnessing here is a fundamental shift in how we build intelligent systems. It's a move away from relying completely on a single central brain in the cloud and towards spreading that intelligence out. And that shift? It's fueling a massive, and I mean massive, growing market for edge AI. And you can see it right here. It's dominated by the things in our daily lives, consumer devices and cars, all things that need to be smart, fast, and reliable, right where we are.
And you know, there's a really powerful business reason for this too. While edge computing can cost more upfront to buy the hardware, it can save companies an enormous amount of money in the long run on operating costs. We're talking about the fees for constantly streaming massive amounts of data back and forth from the cloud. That gets expensive fast.
KITT, at the end of the day, was the ultimate one-of-a-kind prototype. But the technology it predicted, this fast, responsive, local AI, is now becoming scalable. It's something we can put everywhere. And that leaves us with a final fascinating question. What does our world look like when not just one car, but millions of devices in our homes, our factories, and our cities all have the reflexes and the intelligence of KITT? That's the future edge computing is building right now.